if you want to see more of me machining, grinding with no adverts and a little bit more swearing, you can always have a look on my Patreon channel. The link is in the description box. I've got a CO2 extinguisher here. The lad's going to fit it into a rally car, and he wants an adapter to go on the end of there so he can do his own plumbing system. Now I've measured the thread, and the thread is definitely 14 TPI. I'll bring the camera in so you can see it, but it's a 14 TPI thread. In diameter is nothing that matches any BSP thread, so I think what they've done is they've made it a bastard thread so you can't just buy a unit to screw on. Right, so that's 14 TPI, fits in there perfectly. There's no electrical current that goes in, so no, it's a 14 TPI Whitworth foam thread. I'm going to make a boss to screw onto there and adapt it down to that thread there, which is plain old 1/2 inch BSP. I'm going to screw cut the thread, and with it being an imperial thread, I can't disengage the lead nuts, the lead screw, once it's started to cut the thread. So I'm going to turn a bit of brass bar to fit in that. That's the biggest collet I've got. And use a collet chuck, and I can take the collet chuck off and try it on the bottle, because obviously I can't try the bottle on the lathe. But I can take that collet chuck off and nothing will move. I can go back to the way it was and try that onto there. I found a piece of suitable hollow brass bar. The machine that down, part of the length off, and then put it in the collet chuck, set the lathe up, both the sides, and hopefully get some thread screw cut. I've just cleaned the lathe, which is typical, and you get a brass job on it, brass is messy stuff. .30mm is the biggest collet I've got, and this is at 29.14, so it should do the job. Splendid, that'll be ideal. I'll part that piece off and then we'll get it screw cut. I'm going to have a hole all the way through so I can just bore straight through with a screw cutting tool, not onto a blind shoulder. And then I can sort the other end out by probably silver soldering the fitting in, I'm not quite sure. I'm just going to kind of make it up as I go along. I'm not sure what this brass was off, some sort of fitting in the end of it. I got 2 or 3 given, and it really is nice material to repurpose. I could have used that chuck and lifted it on off, but it's a lot easier with a lighter chuck. I need to know the core size of the thread because that's what size you bore the hole. So we'll use the sharp punch on the caliper to measure it. 19.8. So we want a hole at 19.8, and when we screw cut it, it gets the full depth, it should screw on. I'm going to put an 18mm drill through first and then bore it from there. It's not a very good drill. A quick measure of that hole, I think, before we go much further. Yeah, it's only 18mm, so that's fine. Often a blunt drill like this can drill oversize. We need 1.6 out of there, 1.7. Doesn't sound very happy at all, that. In fact, it sounds very unhappy. Don't like that very much. All that's doing is taking a real fine cut just to clean up the rough finish that the last tool put on it. Right, to put a decent finish in there, you shouldn't put your finger in holes, at least not holes like that. And so we want 0.3 out of there, 0.38 out of there. Right, that should be the last cut. Right, dead on size, just what I wanted. Next thing is to set up the gearbox to cut the 14 TPI. I'll have to remove and replace the chain wheels on the back, put some transition gears in, and I'm going to get a screw cut. This is the standard gear setup on the back of this Harrison lathe. With this gear setup I can cut virtually any metric thread by utilising the Norton gearbox that's built into the lathe. But to cut an imperial thread, we need to put a compound gear on a transition gear to convert the lead screw from imperial to metric. It's not a perfect conversion, but it's certainly perfect enough for the sort of machine I'm likely to be doing. It's filthy in here, covered in horrible sticky oil. Definitely a gloves on job. This part here is called the banjo for obvious reasons. So it looks a bit like a banjo. The little key in there that normally falls out, and of course the bastard thing has fallen out and it isn't in the gear. You have to stop at the bottom so the key won't fall out. I think there's a law regarding it called Parkinson's law. Bastard thing. Right, I'll find the key way and then we'll, or at least I'll find the key, or I'll try and find the key, or I'll make another one and then we'll carry on. That's where it goes, in there. There's two gears in here called a tumbler reverse, and they reverse the rotation of the lead screw compared to the... Ah, look at that bastard! We found it! It's a stroke of luck. Right, I'm going to select the gears. I've got a chart here, and this chart tells us what gears I need to cut a particular thread. We're doing 14 TPI. Start off with a 50 tooth on the top. And the two transition gears go in onto here. This is all adjustable so you can keep things in the mesh. Right, next goes a 63 onto there. 63 and a 40. These are the two gears I had to make. And the 63 and 40 give you your transition. Not perfect, but certainly near enough. I think it's a 120 that goes onto there. Right, so now we need to make these all running mesh. We'll do this one first. Right. The noise of these gears when they're running, it's just the way they are. Straight cut gears. Screaming, rattling. Make nasty noises. Then we engage that one into there. So it's a 50 rather than 63, which is fastened to a 40, which drives a 120. And that should give us the correct ratio. You want to make sure that you leave a little bit of slack on this, a little bit of backlash, otherwise the gear's banged up. That feels alright. Some nice thick oil on them. I normally use steam oil. I've got a chart that shows us how to set up this for the 14 TPI, a conversion chart. So we want that one into there. We want both these levers facing backwards and that one facing forward. 14 TPI, that way. Second slot along, that one forward. That should cut 14 threads to the inch. Right, everything's set up now. I've got a screw cutting tool in there. It's a homemade one, it's not the one I normally use. I can't actually find the one I normally use ever since I've tidied it up. I'm just going to touch this off, a very light cut. We're just machining brass, so I'm just going to go straight in. I'm not going to bother using the compound angle to put a feed on that way. We'll zero things up. A little bit of cut on, and once we engage the half nuts, that's it, they stop engaged until the job's finished. Bastard. Of course I've just disengaged the stupid things, haven't I? Ah, John, man. Right, all is not lost because I just did a scrape pass. I'm just going to check that it's 14 threads to the inch in there. That's the problem. I'm trying to make a video and I'm trying to concentrate on what you're doing. You've got to concentrate on your screw cutting for obvious reasons. Just chewing. Right, 14. Right, it is indeed cut with 14 TPI. Now what I'm trying to do is pick up that thread, which is not going to be easy at all. In fact, it's going to be virtually impossible. So what we're going to do, start the lathe up, engage it, then stop it, and all I can do now is move that tool in and out to try and get it to line up with the thread in there. I could do without doing this, but it's how you've got to do it. So now if we loosen that tool off, I can pull it in, see how far away it actually is. Difficult to see in there. I need a mirror really so I can see what I'm doing. To tell you the truth, that's pretty good. I'm going to leave it just touching, start the lathe up, and then I will not disengage the feed nut as it goes through. Right. Now reverse the motor. Back out to 0. A little bit of cut. Forward again. And hopefully it'll pick that thread up. So hard. The tool is very flexible and springy, so we need to do some spring passes to get it, but we managed to pick the thread up again, so all was not lost. It's back to 0, a little bit more cut. Forward again, and on it goes. You've got to get into a routine and you haven't got to change from it, you've got to keep going. It's very easy to mess this up, very easy indeed. And then see what it's looking like. Certainly cut at 14. It's not quite down to full depth yet. Another couple of cuts and then we'll take the chuck off and try it on the job. Right, we'll give it a try. I can see clearly now the thread isn't deep enough, but it is starting. We'll carry on quite a bit deeper than that. Right, so that chuck is now back on in exactly the same place as it was before. Everything's ready to start another cut. You should pick the threads up because nothing's moved. Wind it in, reverse the lathe, back out to where it was, a little bit more cut, forwards, and away it goes. That's looking good now. We'll take it off and try it again. Certainly got a full depth thread there now. Right, John's happy with that, very happy indeed. If anything is slightly on the slack side, but it'll be alright. Once again, it's just time to say thanks for watching, thanks for subscribing. If you haven't subscribed, please do, it does make a big difference. Anyway, thanks for watching.